Many factories operate steam boilers every day, yet few truly understand what determines boiler efficiency. Hello everyone, today I would like to discuss a topic that concerns many business owners who use steam boilers because it has a direct impact on operating costs and profitability. Today's topic is the 3 key factors that determine fuel consumption in a steam boiler. First, let's understand a boiler is a closed pressure vessel that contains water. It receives heat from fuel combustion. This heat is transferred to the water, causing it to boil and generate steam, which is then used in industrial processes such as heating, drying, sterilizing, and evaporation. There are 3 key processes we should focus on: fuel combustion, heat transfer to water, water to steam conversion. Would you agree that if all 3 of these processes are optimized, the boiler will achieve maximum efficiency and minimum fuel consumption? Let's look at each of them in detail. Optimizing fuel combustion. How can we achieve optimal combustion? In practice, 3 factors are essential for efficient combustion. The lower the fuel moisture content, the better. The combustion intensity inside the furnace must be high enough, but not exceed the ash melting temperature. For biomass fuels, the ideal combustion temperature is around 800 to 850 degrees Celsius and can reach 900 degrees Celsius, while coal combustion can reach up to 950 degrees Celsius. The ratio between fuel input and combustion air must be properly balanced. Neither too much nor too little oxygen is ideal. Among these factors, fuel moisture is the one operators can most directly control. Therefore, fuel moisture should be kept as low as possible. The drier the fuel, the more efficient the combustion process. The wetter the fuel, the lower the combustion efficiency. In addition, if fuel feeding matches steam demand and combustion air is adjusted accordingly, combustion efficiency can be maximized. However, in manually fired boilers, maintaining these conditions consistently is almost impossible. Since fuel feeding depends on human operation, there will inevitably be periods of overfeeding and underfeeding. As for combustion intensity, operators have very limited control because it depends largely on the furnace design. If the furnace design is inadequate, there is little that can be done other than using drier fuels with higher calorific value. However, this usually comes at a higher fuel cost. Factor 2, optimizing heat transfer to water. This means maximizing the amount of heat transferred from combustion to the water. Heat transfer efficiency depends on 2 fundamental factors. First, heat from the flame and flue gas must be transferred to the boiler tubes and heat transfer surfaces. The fewer deposits between the hot gases in these surfaces, the better the heat transfer performance. Cleaner surfaces result in higher efficiency. Second, heat must then be transferred from the tube surfaces to the water. The fewer scale deposits between the metal surface and the water, the more efficient the heat transfer. This is directly related to water treatment and scale control. To optimize heat transfer, there are 3 essential actions. First, clean the boiler regularly on a weekly, monthly, and quarterly basis. Ensure that all surfaces exposed to flame and flue gas are kept clean. Second, maintain proper water treatment. Use water treatment chemicals correctly to minimize scale formation and control feed water hardness within recommended limits. For more details, you can watch our video, Why Water Treatment Chemicals Are Essential for Boilers, on the DIVI channel. Third, perform regular blowdown to keep TDS levels within the recommended range. Boiler blowdown should be based on actual TDS readings. For more information, please refer to our video, Boiler Blowdown Guidelines, on the DIVI channel. Factor 3, optimizing steam generation. At this point, many people may think that once enough heat is supplied, water will simply turn into steam. That is true, but the real question is that steam truly dry? Imagine that. Steam still contains tiny water droplets carried along with it. This means the water has not been fully converted into dry steam. This significantly affects boiler performance because these water droplets transfer heat poorly and can actually absorb useful thermal energy from the steam. As a result, the energy content of the steam is reduced. This is what we refer to as wet steam, a topic I have discussed in several videos on the DIVI channel. You can watch our videos about wet steam and steam separators for a deeper understanding. In most cases, operators have limited control over this because steam quality is largely determined by boiler design. However, one important factor to consider is excessive chemical dosing, which can also contribute to wet steam. Many boiler treatment chemicals are alkaline and can create a soap-like film on the water surface. Overdosing may cause foaming and priming, allowing water to be carried over into the steam. Therefore, maintaining proper chemical dosage and keeping parameters such as pH and TDS within the recommended range is extremely important. If wet steam is not caused by chemical issues and excessive condensate is still present in the system, installing a steam separator can significantly improve steam dryness. We recommend using a multi-cyclone or spiral-type steam separator capable of achieving moisture removal efficiencies above 98%. A simple field test is to blow steam onto a sheet of paper. If the paper remains dry, the steam quality is generally acceptable. A boiler is not an overly complicated system. However, to operate it efficiently, we must understand three fundamental processes: combustion, heat transfer, steam generation. More importantly, we should ask ourselves how effectively we are controlling each of these three processes. If you can answer that question, then boiler efficiency is largely under your control. Boilers are not complicated, but misunderstanding how they work often leads to poor efficiency. That concludes today's video. I hope you found this information useful. Thank you for watching, and I look forward to seeing you in the next video.